Hello and welcome to my video, lesson 7.4, reciprocal functions and their asymptotes. So taking a reciprocal just means that we are flipping basically what we are given. So we're taking 1 and dividing it by the expression given. So 1 and dividing it by the expression given. So f of x would go to 1 over f of x. So f of x is just another way of saying the function of x. So whatever your function is, you just do 1 divided by that function. So how does this look graphically? So first of all, we have the most basic equation possible, right? Where we have y equals x. So y equals x. So what can we do with that? Y equals x will turn into an equation that looks like this. Actually, let's make it a little bit bigger than that. 1, 2, 3, 4. Let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I believe. 2, 3, 4, 5, 6. Okay, something like that. Whoops. Something like this. Is that about right? 1, 2, 3, 4, 5. Oh, it should go to here. There you go. Okay, so we have ourselves a little bit of a graph here. So what we're going to do is we're going to draw on it in blue for the first equation. So y equals x, what would that look like? So our first value would go 0, 0. 1, 1, 2, 2, 3, 3, 4, 4. And if you go in the negatives, it just goes down like this. Right? So we're going to go down from here, and we're going to go just straight across all the way to here. Right? So this is our y equals x function. What about our y equals 1 over x? Well, let's just think about this in terms of a table of values. So x is whatever x is. The question is, what does y equal in both of our cases? Right? So y equals whatever y equals in both of our different cases. So just think about what x is. So to start, x is, let's just go with -6 is our most extreme example, right? And then we have, let's go to -1, let's go to 0, let's go to +1, and then let's go to 6. So for a regular function, it's just exactly the same because y equals x. So like this, whoops, those should be negatives like that. But for 1 over x, it would make the y equal -1 over 6, -1 over 1, which is just -1, right? This would be 0, this would be just 1, because it's 1 over 1. And then this would be 1/6. So hopefully it becomes pretty clear that the 0 point is, or sorry, no, when I say 0, that actually shouldn't be 0. That should be not defined. DNE does not exist. Yeah, there you go. So that point does not exist. When we get closer to 0, it's actually going to make the bottom, let's say if we get a fraction of like this, right, in the original x function, let's actually add a couple more. So if we had -1/10 and we had +1/10, well, what would happen to our other function? So over here, what would happen is that it would go to 10, -10, and what would happen over here is that it would go to +10. So you can see as it gets to 0, it gets to be a bigger value. So let's just put some dots down to show something. So first of all, 0 does not exist, so I'm making this line. This is called our asymptote. So x equals 0 is the asymptote. Okay, so now if we go into the negatives, right, if it's -6 for x, 1, 2, 3, 4, 5, 6, then it's 1/6 is the height. So you can kind of imagine how, and then over here, if it's x is 1, so that goes here. And then if you go to x is -1/10, you can see how that goes up positive pretty high. So it goes something like this. Hopefully that works. Oh, actually, my bad. That's in the negatives, so it should be on the other side. So let's just fix that. It should be over here. Okay, and then in the positives, it'll be something like this. Oops. Okay, and so you can kind of see it's a kind of weird looking graph where it approaches this point but never really touches. It's also approaching, so in this case, in this graph, it's actually approaching both the x-axis and the y-axis. So let's try to just plug this into our calculator so that we can see what that looks like. So y equals x will be our blue, and y equals 1/x will be our red. So go ahead, plug that in, and you can see here, now it cuts it off because it's not very precise, let's say, but it should keep going up to infinity. It just can't give a dot small enough to show, or precision enough to show all of that. Okay, but that's what's happening. It's actually going up to infinity. The closer you get to 0, the closer it gets to infinity. Okay, so this is one example. This is the base example. All the rest are actually very similar to this. The only thing you have to do is see where the original 0 point is where the does not exist point is, or the asymptote is. So I guess that's all the way over here. So that's the asymptote. That is this part. Okay, and the other asymptote is always the x-axis. So let's go ahead and try this again in a new scenario. So, all right, so now this new scenario, we have y equals 2x minus 3. What we can do here is we can actually just plot this, right? So we can use a table of values like in our last one, or we can plot this and use some certain points to convert it to our other graph. So -3, and then we know that the slope is like this. It goes up to, like that, up to over 1. Okay, so it looks like this. All right, and so now what we can do is we can notice that our intercept, our x-intercept, is our new asymptote, which is x equals 1.5, okay, or 3/2. Okay, we can also say that where y equals 1, those points are going to stay the same. Okay, and everything else is going to basically just go off to infinity. So that's pretty much all you need to be able to do is recognize that that point stays the same and everything else goes off to infinity. Okay, so we have the regular asymptote of y equals 0. That will always be there, but we also have this other one. Okay, if you want to take a look at this, let's just plug this into the calculator to see what that looks like. And you can see that it looks very similar to what I did. All right, let's take a look at the next one here. You always can pause the video. I always recommend pausing the video in order to try these questions for yourself. So go ahead, pause it, try it out, and see if you get the same answer that I do. -3 and a +2. -3, +2, like that. Well, we don't know much more than that. We could try to see where y equals 1, but that would probably be too difficult. So all we can do is go something like this. We don't know exactly where that would be, but something like that. And that's all right, because that's all we need. Because here this will tell us that we have an asymptote at that spot, an asymptote at this spot, right? So this is x equals -3. This is x equals +2. So that means we can move or get our graph going something like this. Okay, because this is in the positive y's, it's going to stay in the positive y's. And because this is in the negative y's, it's going to be in the negative y's for our reciprocal function, right? And same thing here, this was in the positive, so whoops, that's a bad graph. Oh, it depends on how this actually works out in the end, but it's something like that. Okay, so let's see how this looks in our graphing calculator. I think our graphing calculator will make it look a little bit nicer, cleaner, so you can see. But it's always good to learn how to graph things by hand. So this is x squared plus x minus 6, and this is 1 over x squared plus x minus 6. Let's graph it, and it looks roughly like what I did. Okay, it's not perfectly accurate where you can guess every point, but you know, it's close enough. You can see the rough idea. Okay, last question for this video. Question like this is asking, given the graph of the reciprocal function, what is the original function? So first thing you should do is look for the asymptote, which is the x equals 4 spot. Okay, so that means that we know that this equation would have a spot there, right? Now what you can also do is look for whatever point that's given to you, flip the y value. Keep the x value as is, but instead of making it a half, it's all the way over here, which is 2, reciprocal, right? So with that information in mind, I didn't draw my picture very well, because that should be a 1 over here, but right here, that should be a 1, so that should be the same point on both. And this should be a 1, so that should be the same point on both. So I didn't draw very well, but you get the point. It should look something like this. Roughly like that. Okay, so whatever point that you're given, you can make sure that those points line up. You should be able to make sure that the 1 points line up, so maybe I can draw a better red graph, but you know what, it's not the end of the world here if it's not perfect. Here, let's try to draw a better one. There you go, that one's a lot better. And that one's a lot better. Okay, so now that we've sketched it, we don't actually know, or at least we haven't said the actual value of the graph. But since we have sketched it, we know the x the y-intercept is 0, 2. So if you go y equals mx plus b, we know the b part is a 2. Okay, we can also look at the slope. It's a negative slope, and it actually decreases, or it's a negative slope, so it's decreasing, but it also goes over to the right 2 and down by 1, so negative a half x. So that's because m is the slope, which is the rise. I'll just say rise over run. So if you don't remember that, you might want to look up slope again in one of the other videos. All right, I hope this video helps you better understand reciprocal functions and their asymptotes. Good luck.